Hello, I am David W. Parker. This is Programming Today. I Learned 3D Math Series, episode 44, part 3 of the code from looking at matrices. We're going to be translating, we're going to be getting some translations, we're going to add, subtract, and finally we're going to rotate today. Let's dig right in. So, looking here, we have a matrix created with this array here, and we have a vector created here. We can go ahead and see what we have the original array up there, and then we're going to translate it by this vector. And you can see the translated vector here, and those are the new values. So how does it work? Very simply, adding each of the components to the corresponding matrix piece. Very simple. Similarly, getting the translation is just returning those values. All right, so that was nice and easy. Addition and subtraction are also 100% what you would think they would be. So jump right in. Addition is just going to be setting each of the corresponding elements to the new one given the other element in the other matrix. So the first 1, 1, 1, 1, 1, 1, 2, 1, 2, etc. all the way, and subtracting m 1, 1 from 1, 2, etc., etc. So you can see very simple here. This one plus this one is the new one. This one minus this one is the new one here. So if we're looking at, these are the first array and the second array, so you can see the added values up here are exactly what each of these corresponding elements added together would be, and subtracted as well. So 3, negative 1, negative 1, negative 1, 3, 2, etc., etc. So all super simple stuff. So let's get into some real math here with the setting the rotation. We're going to go ahead and rotate by radian theta of 1.5078. That's just me hard coding that, but you can use any kind of other hand shortcuts to compute radians from degrees and degrees from radians if you want. I may probably go ahead and add that in a later episode. So we're going to go ahead and recreate the matrix given this original array again, and then we're going to go ahead and rotate by this vector 1, 0, 0, and see what we have here. So this is the resulting matrix right here, given the format where each, instead of the singular format up here, we're going to have each row be its own. So 1, 0, 0, 0, 0, negative 0.000037, basically. 1, basically 0, 0, negative 1, and then the same 0.000037, and then we're not touching the translation portion at all, so that remains 3, 2, 1. So let's go ahead and take a look at this one and see how that works. It's pretty simple. This is all from episode 12, so we can jump over here and we can see we have this formula down here for all of the elements within the rotated matrix around an arbitrary axis. We're going to have nx squared minus 1 minus cosine theta plus cosine theta for the first element. So let's go ahead and dive in. And so we have this axis here that represents the vector. We're going to shorthand each of these to x. We're going to compute the length of this vector, make sure it's small enough, and then we're going to convert it to a unit vector here. Make sure it's big enough, excuse me, and it's going to be greater than this. And then we're going to go convert it to a unit vector and make sure each of the elements within the vector here, the vector 3, is translated into unit as well. And then we can actually start doing the math. So we have a few pre-computed values here that we're going to use throughout. Math sine of theta, math cosine of theta, so you could see cosine of theta, sine of theta. And then this 1 minus cosine theta we're going to call shorthand as A. So each of these elements in here used over and over again. And then A times X, A times Y, A times Z. So this would be one element of the X, one element of the X times that, Y times, Y times, Y times, and then z 1 minus, z 1 minus, z 1 minus. So when we're looking down here, we could see a of x, a of x, a of x, a of y, a of y, a of y, a of z, a of z, a of z. And then within each column here, you could see there's an extra x, extra z, y, extra z, and extra x, y, z, x, y, z. So each of those here, 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 and so forth. And then finally, we have the plus cosine, the plus z sine theta, the minus y sine theta. So we have the plus c, which is the cosine, the cosine theta right here. Then we have the z times sine of theta minus y sine of theta. Again, next three rows, or three columns, minus z sine theta plus cosine theta plus x sine theta. So plus cosine theta plus, minus z sine theta plus cosine theta plus x sine theta. And then finally, plus y sine theta minus x sine theta plus c cosine theta, which are these final elements here. If you don't remember how to do math for this, you can check out this full episode 12. But in the meantime, just know that this is right. Again, we're going to keep on diving into code and figuring out how to write all this ourselves. Ultimately, I would say that you're going to want to use a library for all this, and we'll explore some libraries in a future episode. But for now, we're going to write it all ourselves and kind of just figure it out as we go. If you like what you saw in this episode, share this. Give it a like, if you will, on social media. Go to ProgrammingTIL.com and sign up for my newsletter. And have a great one. Thank you.